Hello and good morning, and thank you so much for joining me here in my shop on May 9th. A beautiful sunny day outside. Fantastic. So, what to do with this radio? So it's in working order at this point. I'm sure it's not performing as well as it could. And maybe that's a good issue to look at right now. The next step along the way is to start changing capacitors and hopefully improving the performance of the radio. Why not measure its performance now and be aware of that, so as I'm going through and doing stuff I can detect whether things are improving or not. The easiest way to do that is to put in a controlled signal from a signal generator like that guy over there, and just get some notion of how well it works, and also some comparative notion of how it works, compared to other radios that are in good shape. So I think this one's in fairly good shape now, actually, but better that we experiment a little bit here. My signal generator there has this control down here, which changes the signal by a factor of 10. So down to 1/10, down another tenth, which would be 100th. And it's also calibrated with values. If I calibrate the unit and I were to set this to 1, then that would mean 10 microvolts are coming out of the here and maybe making it all the way to the radio. There's a bit of an upset in the voltage in the circuit, the way you're connecting the signal generator to a radio. But anyway, what I've learned from doing this with hundreds of radios is if a radio can pick up a signal with that setting, it's very good. It's pretty good. It's like any other radio. Oh, maybe it's a little weak because, wow, it needs this much power to make a signal come through. Ooh, that guy's in big trouble because I'm pounding it with a lightning bolt and it's still nothing coming out of the speaker. That's kind of how I assess this. It's kind of a qualitative thing. So just these two settings here, especially the one it's on right now, if the radio can pick that up clearly with that kind of setting, then it's pretty good. It's got a pretty good sensitivity. Now that would be 10 times 10. That'd be 100 microvolts, which for a radio like this maybe is okay. 100's a little high. Certainly for a high quality communications radio, 1 to 2 microvolts is what you have to put on the antenna to get a decent signal to noise. So let's test this guy out. I'll hook up the signal generator straight to the antenna back here, and we'll pump in some signals and we'll see what happens. We can do this on the 3 bands. We can do it different areas of the band. We don't have to go too far in doing this to get a good impression. But really the very first thing I've got to do is I forgot to put the coffee machine on, so I have to go turn that on. Okay, here we go. I'm going to turn on the radio and turn on the radio. There we go. While that's warming up, I'm going to calibrate this. So to calibrate it, you need to have this control set, say, to CW. It can't be set over here or you're reading modulation. It's got to be CW or perhaps this crystal. And then you adjust this control until this is at the max of the meter. That sets the output at 10 microvolts times the multiplier. So right now we'd have 10 microvolts times 10, 100 microvolts down here. Now, how accurate is all this? Depends how accurate this meter is and other stuff like that. Now, modulation, I'm going to put 1000 hertz tone at 30%, which is typical for this kind of stuff. And we're dialed into, can't quite see that, 766. That's nothing. So we'll put on 760 and we'll try to tune that in on the radio here. Why is the radio stone silent? Uh-oh, we're off to a bad start here. Well, barely hear anything there, full blast. But that's why we're doing this. 760. Maybe it'll come whipping in here. 760 is right here. Uh-oh, something not right here. Something's not right. What's not right? I'm on the wrong band. I got this button going backwards. That's what's going on. So, no, maybe not. Phono. Broadcast. It's like there's, well, maybe it's because I clipped this on, but we should be, hey baby. Things are not working out here. Oh, what's happened? Didn't I listen to stations on this radio already? I'm sure I did. Yeah, that's right, because 590 was just almost in the right spot. I remember saying that. Where'd you go, radio? Maybe you scare me. Okay, we're running it with 98 volts. That might be part of the big. How about this? The lead fell off the antenna connection. So that'll explain a lot. Volume down, volume down, volume down. Okay, that explains it. Okay, we're back on. That's a little better. 760. Wow, that is, it's a lot weaker than I thought. Now when I use the antenna in my shop here, I'm using a pretty strong antenna outside. It's an amplified antenna, so it's firing a pretty strong signal down here. Let's just jack this up to a better voltage here. We're a little low. They're still running it through the dim bulb, so we're only at 105 volts, so that should be enough. There's something weird about this. How can it pick up a station? And yet the signal generator is extremely weak. Well, maybe it's just what I said. The antenna signal coming from my antenna is actually quite strong. So, so this is interesting. So we're getting a nice clear signal with that setting, but we should get a similar thing here, I would say, but we're not. So a little weak on the broadcast band. No surprise there. Let's go to the next band. This band is there. We're at 49 meter band, which is around 6 megahertz or so. Volume up. Go in the middle. 6.4. This is much more than the 49 meter band. This is covering quite a bit actually. It seems to have band spread the 49 meter band here. See from the white dots? They're spread way out here, but they're crunched in here. So here we're at 6, we'll put it at 6.5. And we'll dial this down to 6.5. Similarly weak. Similarly weak. Okay, we'll go to the next band. It's funny, huh? I don't know why it's not going click, click, click. Why it's going click, 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 click. Where's all these multiple clicks coming from? Oh, that sounds a lot different. Okay, if we're on the top band now, we'll dial in 10. And we'll dial up 10 here. Ooh! So I'm right at the end of the range here. It's dropping off. Dropping off on the output that's going up here. I don't hear it though. Let's go higher. Let's go up to, let's say 11. 11 megacycles. Don't hear it at all. Okay, up 10. Now it's as weak as it is on the other bands, yet that's a 10 times stronger signal going into the radio. So these are all signs of two possible things. That's dilapidated components, or the alignment is not correct. And it's probably a combination of those two things, making this really a very weak radio, because this thing, we should be able to hear this just like this with this set here. That's really where we should be. And I better check the calibration here. I'm full of crap here, full of crap. Calibration varies tremendously on this thing as you go band to band. I didn't do that right. Now I got it right. Yeah, back up. Where? Okay, now get I can make the opposite statement now. Here. It's not so bad, sensitivity wise. I just changed it to make any difference. Huh. How does that happen? Well, some trouble explaining why this is making no difference. They're supposedly reducing the output by a factor of 10, and it's not changing the radio, and I don't think the AVC can account for that in the radio. Oh well. Okay, we got an idea of what's going on here. It's nothing too surprising. It's a weak radio. That's my meter pointer bouncing at the top of the scale there. Okay. Let me just make sure I got all this off. I'll pop this guy out of his cabinet. And we'll look for some critical capacitors. One I'm thinking of, that's probably in here, is not one that affects the tuning or the radio operation. It's an audio sort of thing. It's not an audio sort of thing, it's an audio thing. Oh, there's the schematic right there. I can look right at it and say, yes, there is such a capacitor in this radio. So what I'm talking about is a grid blocking capacitor. Let's take a look on the schematic here. First off, I really like how they've done this schematic. They turn the tubes from the usual angle onto their sides, so to speak. But what this does is, first of all, the signal just travels through like this. It's no longer going down, shooting up, going down, shooting up. But so, visually it's a little easier, but also it makes the line drawing very simple. See, off all these grids, the lines just come straight down. It makes it for an easier to understand schematic. So, what we're curious about here is on the output tube. It's a good place to start. This capacitor in particular is probably, well, I could be wrong in this, but certainly one of the most critical capacitors in the radio. This guy's job is to, I'm taking it all back now. What have they done here? Oh my gosh, they're using a cathode follower style to drive this. They're not taking it off the plate. Well, it's okay. I can't say I've seen that in a radio. Like, maybe that's why they're doing this driver thing. That must be it. Because normally you would take the plate circuit, the plate signal off of this tube, through a capacitor, and then into the grid of the output tube, and that would be all you do. You wouldn't have this tube in here. But this tube in here, they've chosen to use a cathode follower style, as I understand these. And what's all this stuff? Well, a lot of things here I don't recognize. I'm not familiar with. So this capacitor is still blocking some DC. There's going to be DC voltage sitting here of some amount. I'm not sure what it would be. It might be quite large, actually. I'm not sure. But in any case, it's blocking something, some DC from getting here. But then there's another one, this one here, because of this extra tube. There's another tube in the story here. This capacitor is doing the same job, blocking the plate voltage here from getting onto the grid. These two need to be found, checked, and almost certainly replaced. Now we got another important capacitor here, which is the capacitor for quelling harmonics that are developing in these tubes. So you're not playing them through the speaker at all. This guy, it can change the tone quality in the speaker. So if it's lost its capacitance, maybe the speaker becomes tinny. I'm not sure what to say about that. So these are, and then there's something similar. I saw something similar here, didn't I? Where did I see that? This one. So yeah, so this guy, this looks like it's probably a mica capacitor. It's probably not a problem, but if it were not doing its job right, it would affect volume and tone and other stuff. All these audio capacitors can do that kind of thing. Let's just look at the bottom of the volume control. I'm not, if you can hear all this typing on my computer, that's a cat walking across my keyboard while I'm talking here. So if we look at how the volume's done, okay, so it's going back through this switch. It's probably coming down here. There's some filtering right here to filter out some RF. And then the audio is fed here to the volume control. There's a tap on the back. Oh my gosh, so there's some feedback happening here. What's going on? So the tone control is somehow tied back here. Yeah, I always say when you get to this part of the radio, the engineers have a heyday and they do their own thing to try to get a nice result out of the speaker. And this is where they shine. This is where individual engineers really do their stuff. The front part, kind of not as much, maybe. This audio part, they seem to go crazy on it. So, like in this case, they've shoved another tube in here. It looks like they're using negative feedback coming back this way. I don't know. All kinds of stuff going on here. So the radio sounded okay, if I remember right, just low on volume all the time. And that could be these capacitors I'm talking about, or maybe not. But these are the ones we should go for first and clean up the audio side of things. Now there is a diagram that shows me where each of these capacitors actually is, so this is going to be quite easy to do. Fantastic. To work on this radio, I really want to turn it upside down. I don't want it standing on its speaker, and if it's on this end, it's totally unstable. So this is just one of those shelf things you buy, you know, for your kitchen cupboard, and I happen to have one here that is small enough to sit like this. I'll just flip the radio right over on it. Sounds easy. Not so sure it is. There we go. Okay, this will be much easier to work on now. So we're going to want to locate some of these capacitors, and the easiest way is to make use of the diagram that's available. So I'm going to get that set up, and where is the output to? It's right here. I mean, so you can look at that. That's probably one of them right there. That doesn't even look. Yeah, I was going to say it doesn't look original. It's one of a kind here. This one looks a little different too. I wonder. I mean, somebody put this cord in. somebody put this transformer in and did a bad job soldering right there. Somebody could have done more to this, and I haven't really spotted it yet. Yeah, okay. Hey, who put that in there? Oh, that's me. Okay, right. I'll get this set up so we can identify some parts. Okay, let's see if we can get oriented here. So I see this guy here. Oh, it's on the other. How about this? Okay, there we are. Now it's matching up pretty good. And the print is probably too small for you to read. And I forgot the capacitor numbers and everything. I didn't mark them down. So I'm going to stop and just get a little more ready to do this, and then we'll find the capacitors in question. We're going to perform tests on them ahead of time to see if they are leaking or if there is actually this problem that I'm referring to, which is excess voltage leaking, excess current, I guess, is what leaks through the capacitor to charge up the grid on the output tube inappropriately. Okay, I'll get ready here. Okay, here we go. Get a pointer here. Well, this is pretty suspicious. Does this show up in the diagram there? See how it's on an angle this way? Well, that's how it is in the radio, but on the diagram it's not going to be on an angle like that. It's going to be located roughly in this position, and most importantly, well, if this is a replacement, then yeah, none of what I'm saying is true. It's on this terminal and this terminal. Okay, let's see if I can spot this. I'm looking here. It would appear to be this one right here. C28.01. C28.01. We'll flip to the schematic. Schematic, please. And we'll go C20. It looks like 28. Let me zoom in a bit here. I think we found the first one. Yeah, C28. It probably says 0.01 here as the size. Probably going to be the same over here. 0.01. In the parts list, it tells you what kind of capacitor this is. Let's try to find that. Parts list. Didn't I see a parts list, or am I imagining it? I'm looking at too many different radios all the time. Here we are. Parts list. So it's C28. 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 Doesn't say anything here. I'm thinking of another. Oh no, it does. See? Mica. If it doesn't say mica, then it's not mica. That's what I would conclude there. These are probably all original. PP. Paper. I don't know. PP. I'm sure it doesn't mean just paper. It must mean something more than that. But that would be it. And so what's in there though is not a paper. Wait a minute, how do you read this? Okay, I'm just having a moment here. Okay, everything's fine. It's a molded capacitor in that it has a molded shell on it. But inside, oh my gosh, look at the, well no, it's okay. Everything's okay, Jim. Be calm, be cool. I'll bet you this is a replacement. Now when I look at how it's soldered in, you know what, I can see that it's been, the way the wire is looped on the outside of the terminal. I'm sure this is a replacement. So, and then this one's probably a replacement also. Let's see if we can figure out what this one is. This one's also coming from the output tube and running over to the, this is the 6J5 here. Another capacitor. Oh, you know what? Maybe that's 28. Maybe that one's 28. There, let's just zoom way in on this area here, because this is what we're interested in. So there's one here. This is a resistor here. We have a capacitor like this. And I can't see where this is going. Probably going here though. So okay, looking back in the radio. So that's this one again, coming here. The other one's up on a higher terminal. It's up here. This is this one. This is at C29, 0.005. So when I look at it, it's a 0.0068. This capacitor, 0068, and they got it 00. That's either a 6 or an 8. I think it's a 6. So that would again suggest a replacement's been done, and rather than get hit this size exactly, they just put something in very similar. So someone's been here and done exactly what it is I'm heading to do now. Well, let's see. These capacitors are not new today. They're old now too. They've gotten old. they have not stayed young. So what we can do is we'll do the test. The test will tell the truth. Now, practicing for the test. So what we do is we go on one side to look for the voltage that it's holding back, and the other side to find out how much it's holding back. It should be all of it. I should be able to go here, find some kind of positive voltage on the meter. I can't remember what this, but whatever it's going to be, and then I come over here and see that it's 0. Now wait a minute. No, there's 2 coming over here. What? Why 2? Let's just go back to that schematic again. Schematic, please. What would you do with it? Okay, and what we want to figure out is what was it we want to figure out? I can't seem to hold a thought very long in my head. The 2 capacitors, what are they doing? So one is on pin 1, 2, 3, and the other one's on 6. Are these numbered? They are numbered. So one is on 3. Oh, over here. Good luck trying to read these numbers. Look at that. That's a number. Okay, can't read the numbers, but I can. And that's not going to help then, because the way they're showing these tubes, the numbering is not sequential. Okay, so I gotta get my little book out here, and we're going to look up 6V6. 6V6. Do you notice when you grab a book and you go to look in it, you don't have to wait for it to boot up first before you open it up and start looking? Let's see. 6V6, and so in here we've got one of those capacitors is on 3. 3 is a plate, and so we know which capacitor that is now, and the other capacitor is on 3, 4, 5, 6. Is that right? 3, 4, 5. It's on 5, and 5 is the grid. So this guy is the grid blocker. And this other guy is probably a harmonic killer on the plate. I'm not sure what it's doing there. I have to look again on the schematic. Oh, it's up on the screen. Okay, so if we look again at this capacitor, that's the grid blocker. This is the one. I think this is probably the one I'm looking at. Actually, I got it all mixed up because it's coming off the. See, it's hooked up to 2 tubes. I bet you this is some kind of, I don't know what this is, some kind of ground. It's connected to another pin, the big black wire coming to it. This just might be a handy ground point. So we could consider that. If we look at the 6J5, it's pin 2 on the 6J5. Can we see 2 on here? Maybe could be that. And you see the other side is grounded. Could be they've reversed these. I'm starting to stretch it a little bit there. It's definitely 2, eh? 1, 2. 2 and 7. So if 2, then 7 would be the feed. 7 would be this guy here. And it's a wire that's snaking its way through the. So I think that's what's happened is they showed it one way on the schematic. They actually wired it the other way around on the radio for some reason. So this is going to ground, and it's on the plate. The plate is yeah, and then the plate feed is going out to output transformer up on the speaker here. Oh, you can't quite see that, can you? Well, I guess you can. So it's all making sense. So the purpose of this thing, though, I feel like I'm going over the same territory again. Yeah, so this is on the plate side of the output tube, right near, you can see it right here. And it's a 0.005 it looks like, so I think it has been replaced. C29, I would say. If this is 28, this is probably 29. If we look at the list, where's the list? 29. Where are you, 29? I can hear birds singing outside. I don't know if that comes across on the video or not, but I don't see 29. Oh, here we are, 29. Yeah, 005. PP. PP. Okay. Okay, I don't think I don't think there's any more information I can get in my head before actually doing this. So let's do it. I'm going to use this voltmeter over here, which you can't see right now because of angles. See if I can fix this up a little bit. Okay, not the best camera arrangement here. Let me put this over here. So you really won't be able to see exactly what it is I'm contacting, but I'll tell you what it is, and what's important is what shows up on this meter. Okay, again, let's get this. We're all set. We're plugged in. And volume down, up a little bit. Switch is on. Power is on. There we go. The meter here is set way too low. We'll set it 150 full scale to start with. We'll see where that gets us. Just give a minute for the radio to warm up. We're only at 92 volts. What I'm going to do is I'm going to take the dim bulbs out of the circuit here. We're at we want to be close to the real line voltage, a little higher yet. 110. That's good enough. Okay, so here we go. On the, let's call it the high side or the hot side of the blocking capacitor, we get, and I'm going to get my arm in the way here, we get that. So 130 volts there. But on the other side, not a thing. 1.5 volts. Next to nothing. Good. There's no reason to worry about that one. Now the other one, one side's grounded, so the same test process that doesn't work at all on the other one. And the rest of the tubes, their grids are fed from transformers, so they don't have this leaky capacitor problem. So so there's no gain to be gotten there, I would say, unless for some reason there's no capacity in here, which there's no reason to think that. Okay, we didn't get anywhere there. We have a weak radio. The audio appears to be good. Why don't we test that directly? Because I can feed an audio signal into here. We can listen to it come out the speaker, and then we can kind of get a feel for whether that's good or bad. Then maybe I'm just going to ignore the audio circuits from there. Wax capacitors and all. Okay, yeah, that's what we'll do next. The challenge I have with doing this is I don't have a calibrated source of audio that, or I don't, like, I'm not really going to be aware of how strong the audio is that I'm feeding into the radio, so the response out of the speaker is going to be a little wonky. Why is this doing this? So we'll get this down into oh, I touched it and stopped. What happened? So we're going to, let's try with just 1,000 hertz right now, and why isn't this showing it? Something going wrong here already. Loose connection. Overflow. Too low. Oh, you know what? I haven't turned it on yet. That can make it unstable. Yes, okay. So I have an amplitude control here. I have some attenuation buttons here. These ones are marked 10, 20, 30 decibels, but this is not calibrated. There's no meter on the front. There's no way to know without an additional effort to figure out what the strength of the signal is coming out of here. Let's make sure we're on audio, and we want to be up around 1,000 hertz. So that's 1,000 hertz now coming out at some level, some low level, because these are all, actually push these in to attenuate. So we've attenuated the signal 30, 60 decibels from whatever this setting is. It will turn this up. I don't know. Let's just do it. Let's do it. Do it. Do it. Okay, radio's on. Yeah, I'm not sure what I'm doing, but let's do it. So this is the output cable from the signal generator. I'm going to go into the audio as soon as we get this operating. Volume controls here now. And the band switch is this guy, and we want to switch it to phono. So I think that would be phono. Phono? That's a good test rate. You know what? That's a good test rate there. I'm ungrounded, by the way. I would never do this if I wasn't feeling safe and secure. I also have this plugged into an isolation transformer, so the idea of me getting a ground shock off it is a little far-fetched. Any significance, anyway, is far-fetched. So I can do this kind of stuff fairly safely. But if this were plugged right in the wall, it could still be fairly safe, because the transformer itself, this one, is its own isolation transformer for the rest of the radio. So it all depends on a lot of things, but it might still be safe. Volume up. Don't touch two things at once, that's for sure. Volume's right up. That's all she's got. That's not too impressive. Okay, we're going to put this in here. We should now hear 1,000 hertz tone. We should hear 1,000 hertz tone. Okay, volume about half. We'll start cranking it up over here. Oh, I hear it. So we're at max output. Cut this down. We'll take these. There it is. Now, what do we make of that? This is the problem. I don't know. I mean, perhaps I'm blasting a signal into here. This is intended for around a volt of signal. Can we measure it? Why can't we measure it? We can measure this, can't we? We'll flip this to AC. Put this down. I don't know if I can actually measure this, can I? Maybe not. The zero's way off. So I gotta flip this switch here. That's very, very important. Tiny, tiny amount. Yeah, it's probably millivolts of audio coming over here. I don't really know. That's the point. I don't really know what I'm doing. Let's change the tone up and down, and we'll kind of get a feel for the speaker here. Well, I can even hear that. I don't know if that comes through on the video or not. But now what I might be hearing are harmonics, because according to my signal generator, it's putting out 10 hertz. Can't hear 10 hertz, but maybe there's 20? That sounds way higher than 20. 30. That just sounds like 300 to me. Oh, is that what that really is? Anybody know how to work this? Kilohertz. 0.3 kilohertz. It's 300. That's 300. 300, 400, 300, 200, 100. That's why I can still hear it. You probably can't. But it's reproducing somehow. Oh, we'll go up now. 100, but we really want to go up to 10,000. That's 10,000. I don't hear anything, of course. 9. Oh, I can hear something there. At 8. Now again, it's harmonics, weird stuff. Is that really 8 kilohertz I'm hearing? Okay, we'll do the rattle check. Put it down to a lower frequency. 300. Crank it up. Crank it up. Now, the problem here is the distortion may be coming from too much signal coming in. I'm looking for the speaker itself. Turn that down, we'll turn this up. It's buzzy, sounds buzzy to me. What am I proving? I don't know. I don't know. Let's go low, go low. 10. Any rattling? No. Okay, this is it. I've goofed around enough. Ooh, I turned it up full. Okay, well, we know it works. We don't know if it's really working correctly. It doesn't seem to have any problem with the speaker. It seems to have a nice frequency range, like a wonderful frequency range. It can reproduce 100 hertz. That's pretty good. Put it in a cabinet, you can probably hear down to 60 hertz or something of that sort. That's quite low. And yeah, because out of the cabinet, the low tones in the speaker get shorted out because it's not in a baffled cabinet anymore. I better turn the power off here before I shock myself by accident. Okay, I didn't get anywhere. I didn't do anything today, but I've run out of time. So basically what I discovered is the audio circuits seem to be fine enough on their own. Somebody's come in and taken care of the 2 critical capacitors. You could assume they really knew what they were doing, and so all these other ones are less critical and can stay in the radio, and the radio can still operate fine. But it's not operating fine. So my guess is maybe the next thing is to do an alignment. I usually find I have to align a radio twice. First time is practice, and then the second time is for real. That's usually how it works for me. So maybe we'll do that, even do the practice session, and maybe find out in the course of doing that there's more trouble in the radio I can locate. But I bet you if we just do an alignment, this radio will be good enough to go. That's for tomorrow. Today I gotta go out and enjoy the sunshine while it's here. My city of Aurelia, where I live, is known as the sunshine capital of Canada. It's very sunny here in the summer. I think there's other places that are actually a little more sunny, but this is very high on the list, so lucky, it's a great place to live here. Okay, that's it for me, and tomorrow will be, I don't know what I'm going to do tomorrow, we'll see. Ciao.